Okay. Thank you, Joachim, and thank you for everyone to be here today. We are from Juliasoft. I am Sanna Kallio. I deal with our international business area. So mostly today we'll be talking my colleague Pietro Ferrara, who is our research and development, the head of our research and development. If you are interested in our products, in learning more about Julia, please contact our distributor in Scandinavia, Nohau. And then, of course, I'm also available for any more information. Since most of you probably attended also the webinar last Friday, I'm not going to do reintroductions of the company. Today, it's going to be mostly a product demo. So just 2 words for any of you who connected just today. We are a technology company. We specialize in software verification, in particular in the static code analysis. And we offer services and solutions for semantic analysis of software code. The solution suite is composed of the analysis engine. We analyze Java, .NET, and Android code. We do a very deep analysis. It's based on a formal method and is able to do a semantic static analysis of software compared to pattern matching, to syntactic, which is the technology most competitors do. We look at issues which have to do with, of course, quality, security. Also, privacy is something that's becoming quite important for companies. And then we also integrate our technology with our partner Grammatech, who have a static analysis tool for C and C++ code. So this compiled technology is also able to look at environments, especially in the IoT context. On top of the static analysis tool, we also offer a KPI dashboarding feature. So basically today, what you're going to see is Pietro, who will show you the various features of our technology, our tool, and also a quick review of the dashboarding feature. So please, Pietro, I will leave it to you. So you'll probably connect into.
Yeah. Okay. Great, thank you very much for the introduction. And essentially what I'm going to do is to start where we ended last time. So if you remember at the very end of the webinar of last week, we connected to portal.juliasoft.com. So this is something you could do right now. So these are our cloud services. From here, you can just register a new user, then you get a login and password, you activate your account, and then you can simply log in. So once the first time you log in, there is a quick start. So I'm going to drive you a bit very, very quickly on this quick start. So as we discussed last time, we have support for different IDEs like Eclipse and Visual Studio and IntelliJ IDE Android Studio. So the demo I'm going to give you will all use Eclipse, but the plugin for other IDEs is identical in the sense that we have exactly the same panels, wizard, and so on. So what you need to do, first of all, is to install the plugin using our URL, and then you can set up your preferences. So I'm switching to the plugin. So after you install the plugin, there will be a Julia item in the menu. And from the preferences here, you can set up your account. So we are connecting to portal.juliasoft.com. So all the demo I'm giving you today will use our public cloud services. If you have, if you buy our license or you do a trial, on-site trial, you will have here probably a local URL like, I don't know, localhost or this kind of URLs. And then access and secret keys. And these are provided through our web console. So inside your account, here you have your credential, your access key, and you can generate new credentials. When you generate it, the security key will be shown once, and then you have to register it inside your plugin. Then you can do a test connection just to check that everything is working. You select the solution. So for the purposes of this time, I'm just using the default solution. And now, more or less, we are ready to start the analysis. How do we start the analysis? So first of all, we need to have a project, an open project. So the demo, the first part of the demo will be focused towards web code. So what is web code? It's an application developed by OWASP for let's say, teaching about security vulnerabilities. So it's a rather good target to show many different kinds of nasty bugs you might have on your project. And this is usually what you use for demo purposes. So we have this in our Eclipse workspace, and then we can open the wizard to launch the analysis. So as I was saying the other time, a static program analyzer needs two things. The first one is the program. What kind of program you want to analyze? Here we have just the WebGoat project, so we can select it from the left part. On the right part, we might select what kinds of dependencies of libraries we want to use to run the analysis, but to keep the analysis quicker, I just select only the main project. In the second panel of the wizard, there are some general options for the analysis that might be interesting if you have really an advanced use of Julia, but in general, you don't need to touch these options. And in the third panel of the wizard, you have the second component that is very important for the analysis, that is what kind of properties you want to analyze. Julia checkers are divided into basic and advanced. So usually what we do is just run all the basic checkers. So these checkers are rather, let's say, fast. The analysis over the WebGoat application that is about 20,000 lines of code take about 1 minute, depending, of course, on various things, but it's about 1 minute. Among the advanced checkers, one that is particularly interesting is the injection checker. So for now, I will just focus on the basic checkers. We can also save the configuration with the name, let's say, let's call it demo, okay? And we save it inside our configurations. And later on, we can just select from here the, I got a problem with the Eclipse. However, we can just select it later on inside the configurations, and then we can click Finish and launch the analysis. After the analysis is launched, I already ran the analysis, because when I'm using the public cloud, what it happens at the beginning, here we can see the full log. I ran the analysis a few minutes ago. We get that analysis get queued. So depending on how many other people are running analysis, this might be queued for several minutes, let's say. Of course, if you have your own virtual machine, it will be executed immediately. And something very important about our analysis is that the only things that you can see it from this line that we upload for the analysis is the jar file, because Julia analysis runs on the bytecode. Then the analysis starts. And when it starts, essentially, first of all, there are the, let's say, standard syntactic preprocessing. So we unpack the jar file, we extract the bytecode, we have our own internal representation of the bytecode, and then the more semantic analysis starts. So we have a class analysis. Of course, this log is not complete. It reports only just few of the processing that is done by Julia. And then you can see here all the different basic checkers are run. And at the end, in this case, the analysis was extremely fast, just 40 seconds. Usually it's about 1 minute for WebGoat. And then the analysis is completed. So far, so good. We have a Julia analysis view. That is what I had opened before. Here, after the analysis is finished, we get the results. So as I was telling you the other time, the results of a static analyzer at, let's say, the finest level are a bunch of warnings. Of course, the warnings of Julia are structured. So in this case, the first time you are using the plugin, the different warnings are grouped first by the type of warning, if it's a warning about bug, efficiency, or style issues. Then the severity, if it's a critical, major, minor, or info warning. And then the type of the warning. So now I'm going to drive you a bit about a few of these warnings, just to give you a clue about how Julia reasons and also how you should read the warnings of Julia. Let's just to open the first one. So the first warning is just saying, let's read the message, because this contains often quite useful information. Here it says, look, we are at this line of code. We are calling update lesson status with some parameter. It says, look, are you sure that the actual parameter employee that is passed to this method is effectively non-null? Looks like there is a null constant from line 87 that goes into this. Okay, we can see here we are at line 74. Line 87 is later on. So what happens here essentially is that we have a parameter employee that is passed to this method call. This local variable employee is initialized with the result of a method called to get employee profile. So we can just jump inside the get employee profile, and we can see that here at line 87, a local variable profile is initialized to null. So here we can see that we have this semantic analysis performed by Julia that is giving you some feedback looking to the whole program. So also how different methods might call each other. So here we jump to this method. We can see this variable is initialized to null. And from the message of the warning, we knew that there was this null value that might be going into that method call. So let's inspect manually now the method. We can see variable profile is initialized to null. Then we have an SQL query. Then we execute the query. So what might happen here is that, maybe the connection is broken or whatever. So an exception might be thrown. So we might get into this catch statement. So profile might be null because of exceptions. But also we executed the query, and if the query returned at least one result, so answer result.next returns true, then profile is initialized to a non-null value. So all in this case, that is, when there is no exception thrown by opening the connection, and when there is at least one result in the result set, then profile is initialized. Otherwise, we have seen profile might effectively contains the null value of line 87. Okay, so far so good. However, I think you might think, it's not so bad that you are passing a null value to a method. This is often accepted. The important thing is that effectively the method that you are calling that might be receiving a null value, check the nullness of the parameter. And of course, here we are talking a critical bug, okay? So it's really a serious issue. This means that Julia got evidence that indeed what you did with this parameter here, for instance, at line 189, is to dereference the parameter without checking previously its nullness. So that's why we get here a critical bug about the nullness issue. We have also quite some other warnings about nullness. Like, for instance, here we get a warning, and we always need to read the message saying, look, the receiver of method toString, we can see this person line 879, sorry. Are you sure it's not null? It looks like there is another explicit null constant from line 61. So in this case, it's similar to what we had before. We have something that is initialized to null. Then we have a try-catch statement. So here we might get different types of exceptions that are caught by the statement line 74. So effectively here, person might be null. Another nullness issue, for instance, so here you can see this that I'm showing you at the beginning of this demo are all nullness issue, is about returning null instead of an empty array. So here we get the warning saying, look, always read the message of the warning. You are returning null for an empty array, and I see that this is later dereferenced in a catcher class at line 104. So let's open the catcher class and let's jump to line 104. And we can see here that there is a method call to the method on which we got the warning because it was returning null. And this effectively just accesses immediately the first element of the array without checking the nullness of the array. There might be other cases. So in general, it's a quite bad style practice to return null for an array. So I can see here that inside the style minor issues, that there are warnings of the same class, of returning null for array warning. In this case, what we got is that we have a method returning null instead of an empty array. But what Julia didn't find in this particular case is a caller of this method. So let's ask the Eclipse if it finds a caller to this method. So we can see that there was no caller inside the applications that we analyzed. So Julia didn't get any evidence that the method that was calling this one was dereferencing the return value. So this is just a minor style issue. It's something that maybe you might take care about that, but only later, only after you have, let's say, worked on, say, on bug critical issues. So Julia performs a wide range of different checks with the basic checkers, and quite few of them are about, let's say, more object-oriented issues. So for instance, here we have a string, login ID, that is compared to an empty string using the reference comparison. And this is totally wrong. You should call, and this is what is written here inside the message of the warning, you should compare using the equals method that is defined for each object in the Java programming language. Similarly, here we have a compare to method. So what is a compare to method? It's a method that should return 0 if two objects are the same, or another integer value if they are different. Here, the message says, look, you are defining on this class compare to method, but this seems inconsistent with the method equals that indeed is inherited in object. What happens in this class? Well, this class requests parameters, implements comparable, effectively implements the method compare to, but it doesn't implement the method equals. So it should override also method equals and say, look, in this case, two instances of this class are the same, for instance, if their name is the same. So also this kind of issue is really typical from an object-oriented perspective. And this is very important, in particular, both the previous one about the equals method and this one, when you are using instances of this class inside a collection. So if you put, for instance, inside an hash set, something for which you didn't define, for instance, let's take no hash code. So you define the equals method, but not the hash code methods, then inside an hash set, things might be very wrong. You might add twice the same element, and you get the element twice, the same element twice in the collection, in a set. That is something that logically is wrong. Or you might try to remove an element that instead, indeed, it's equals to an element that is in the set, but has a different hash code. So all these kind of issues are typical for Java programs. We have also other checks, for instance, about numerical issues. Of course, these are, let's say, less relevant for object-oriented programs than for embedded programs. So we have some checks, but not very, very pervasive like what you could expect from the, let's say, safety-critical embedded world. So in this case, what we get is a warning saying, look, you are comparing two non-integral numbers. We can say that calc total is float, so the equality we are applying here is between floating point values. So this calc total is the result, not going into all the flow inside the program, but it's some computation that was done at some other lines of code. And you have an equality comparison. Because of approximation, instead of doing the equality, you should just check, for instance, here we have equals 0, if this value is less than some epsilon and greater than some minus epsilon. So also this kind of checks are performed by Julia. Now let's go into some other issues, for instance, bug major. In this case, here we are going to something that, let's say, Julia thought was less relevant. So here we can see that we have some statement, and this statement assigns a screen to a new value. And what happens here is that Julia says, look, screen is a parameter of this method, and you write it before reading. So we can see that screen is written here, but it's not read before. So probably what the developer wanted to do here is, instead of checking if S is null, you should check if screen is not null. And only in that case, you should initialize the parameter. So this is another example. Then we have typical issues about casting, dynamic casting in Java. So for instance, here we have a request. It's a parameter. It's a servlet request inside this method. This is casted to a subclass of servlet request, HTTP servlet request, without checking anything. So Julia reports a warning because this might cause a class cast exception. So this might break down the execution, let's say, a normal execution of the program. Then we have also some checks about the value. So we have dead code checks, or like test is predetermined. In this case, what we get is here at line 43, we have that the result of this text is fixed because we are comparing an array list created at some other point against null. So we can see here that this hint is initialized with the return of a method. And we can see, if we inspect the code here, this method is implemented only once, that is reported inside the warning message, and this always returns a non-null result. Okay, then you can go ahead and inspect more warning, but I think for the purposes of this demo, I would stop here. What is very important is that each warning comes with some information. So let's open again the first warning I showed you at the beginning. We can see here on the right side of the Julia analysis view results that we have quite a lot of information attached to each warning, not only about the type of the warning and the severity, but also, for instance, the CWE identifier. So the CWE is a catalog of common issues in software. So each warning has attached a CWE identifier. So maybe this first grouping was fine for you to inspect just a few warnings at the beginning, but then you want to focus on other things. So you might start to group warnings, for instance, first for package, because you're interested about specific issues in the package. And then maybe you are targeting some specific CWE identifier. So you can just group them by clicking on this button. And for instance, I don't know, we might open the client-side filtering. And we can see that in this package, we get only 11 warnings, and a few of them, let's say only one is about CWE 400. And in this way, you can navigate the different results. So this was about the results of the analysis. And as I was explaining the other time at the end of the first webinar, inside the software development lifecycle, the integration inside the IDE is mostly for developers. So essentially, you wrote your code, you get your warning, and then you want to jump inside the program, inspect the message, and maybe take action, fix your program. However, this is just one view of the results. So another view that we have of the results is the view in our web console. So here we're going back to portal.juliasoft.com. Inside our web console, each analysis has its own view. So in this way, you don't need to have the plugin installed inside the UID and so on. And you can just see in HTML what options you selected for the analysis, the checkers you applied. So here we have the full list of the basic checkers we ran, the files we analyzed, the webGoat. There are some statistics and some summarized view of the results, like out of all the issues, how many were bug, efficiency, and style issues, checkers, and so on. And at the very end, sorry, here, we can also group the results of the analysis, so the warnings, in different ways, like what we have done inside the Eclipse plugin. But we have also other output files we can find here. We have a PDF file containing a PDF of the results of the analysis. So here you get a wide range information at different levels. So how many lines of code you have analyzed, about 20,000, as I was saying at the beginning. Just a quality score that is given to your program. Different summarized view of the results with respect to some standards of the community and some categorizations performed by Julia. And at the end, you get, let's say, the laundry list of all the warnings produced by the analysis. In this way, you might also store the results in a viewable way, or also transmit them by email to somebody that does not have access even to the source code. So if you have third-party software, you might ask to people providing you such software to revise some of the issues that were found by Julia. We have also an XML result of the analysis, and this contains all the information I showed you in the other components. So here we have some information about the analysis. The analysis completed correctly. It took like 40 seconds. We have the complete list of all the warnings here, and you can see that for each warning you have different types of information, from the CWE identifier to the type of issues, the rank, so the severity, and the type of the category. And at the end, you get also the configuration of the analysis, all the checkers that we run, and the formatted run duration, and so on. So in this way, you might also want to parse the results of the analysis, in particular, if you want to integrate the analysis of Julia in a continuous integration system, let's say like in Jenkins. So how does it work if you want, for instance, integrate the analysis inside, let's say, Jenkins? What you can do is to build up a Jenkins task that executes Julia. So far, I showed you how to run the analysis using the Eclipse plugin. Another way to run the analysis is to use our shell client. So this is just a jar file that you can run, in which you need to pass some option, just saying, look, now what I want to do is to analyze something. This is the URL I'm using, so the cloud services of Julia. We have access a secret key, the jar file that I want to analyze, with what configuration. I will show you the configuration a bit, what solution, and also what framework, so the Java framework. So what happens at the end of the analysis is that you get the XML file, like this one, with the results of the analysis. So then you can pick up the results of the analysis, parse them. Maybe you might create some issues, let's say in Redmine or in Jira, or even in case just send some notifications email inside your continuous integration system, and ask people to take action. So what is a configuration? I think the best way to see configuration is back to with our Eclipse plugin. Is something that, as I was telling you at the beginning, allows you to select what project you want to analyze, but the configuration does not really need. So if you run it from the shell client, you can ask what software you want to analyze, but in particular specifies what general options you used and also what checkers you want to run. As a last component, I'm going to show you our dashboard. So in the very last step of the software development life cycle I showed at the end of the last webinar, we were talking about summarized view of the results. So let's say at the end of the analysis, when you want to integrate all the different software components of your system, and you need to push to some C-level managers, for instance, all the results, and also an estimation about what's the quality, what are the possible issues of your software that also you have fixed from one version to the other. Of course, then you are dealing, let's say, with people that want to see summarized view of the results. They don't want to know that there is a warning at line 74 about a nullness problem because a null value might flow from some other program point. They want to see how the project is behaving, let's say, from the high-level point of view. So they want to see, for instance, vulnerability scores. And this is a standard from the community. So this is the CVSS base score, a quality score that is also, for instance, reported in the PDF report. How many issues you got, not only, let's say, the Julia findings. So this is a demo we have where we collected together results of the analysis over many different projects, as you can see from here. But also out of these thousands and thousands of issues, which one are more important? Then here inside our dashboard, we are using different standards from the community. So for instance, out of 12,000 warnings, 73, only 73 refers to OWASP top 10 issues, and only 110 refers to SANS 25. So here we have different views of the results that allows us, for instance, to see, let's say here, different statistics. So about all the warnings, how many were about style, bug or efficiency issues, critical, CW identifiers, and so on. But also with respect to the standard of the community. So for instance, here we have the OWASP top 10. So as I showed you in the summary view of the results, we had 73 warnings referring to top 10 issue, OWASP top 10 issues. And we can see here that we can also select some of these issues. So here a manager, what could do is just to say, look, I'm really taking care only about these issues that are issues in the top 3 categories of the OWASP top 10. As soon as we put this filter, if we go back, for instance, to the summary view of the results, we will start to have summaries just looking to these issues. So We selected 21 issues, and they were contained in these types of projects. Also, what our dashboard provides us is an action plan. That is, if out of the 12,000 issues we had at the beginning, if we fix just the 21 issues I selected, how the project will evolve, we can see here on the left side of this panel, we get the initial vulnerability score, the max CVSS base score, and also the CW identifiers more relevant that we got. On the right side, we see how the results of the analysis will end if you fix that warnings. In particular, we can see here that the vulnerability score will go from 5.2, will go up to 4.8. Why I'm saying up? Because for the vulnerabilities, the CVSS base score, 0 is the best and 10 is the worst. So 4.8 means that we went up, that the things are improving. And also, before we had issues that were scored 7.5 by the CVSS base score. If we fix that 21 warnings, we will go to a situation which the worst possible warning from a CVSS-based perspective will be about 5. So here we can start also to build up action plans and ways of deciding how we want to act based on the findings that we got from the results of the analysis. Now I would just switch for a bit, let's say 5 to 10 minutes, to security issues. The other time we talked a bit about the OWASP benchmark. So here I have just a couple of slides about the OWASP benchmark. So what is the OWASP benchmark? It's a free test suite published by OWASP. It's not probably the most popular project. Definitely the OWASP Top 10 project is the most pervasive one. It's one of the many projects developed by OWASP, and it consists of 2,700, about 2,700 Java test cases that are marked by OWASP to be vulnerable or not vulnerable with respect to a specific security vulnerability. So each test case contains a CW identifier, and it says if it's vulnerable or it's not vulnerable. If you remember from the other webinar, Julia performs very well on these benchmarks. So here I had a demo with Spotbugs, that is the free tool that performs best on this benchmark, and our results. Inside the benchmark, and also inside the OWASP Top 10 issues, we have different types of issue. And the category in which Julia performs very well is injection. However, there are also several other categories in which other tools performs as well as us. For instance, issues about weak encryption. These kind of issues are quite easy to catch by means of static program analysis. What is weak encryption? You are using a cryptographic algorithm that is outdated. So essentially, you have a method call to an API that is more or less deprecated. Pretty easy to catch them. So here, both, for instance, Julia and Spotbugs performs quite well. You just need to check the method call of the method retrieving encryption algorithm. We have problems about insecure cookies. That is, you create a cookie, you put it in a response, but you don't call the setSecure method on the cookie. So the cookie is not secured. This is a bit more difficult, but it doesn't require really the big semantic analysis we told you the other time and that I was showing you on the nullness issues. What is very important for us are issues about injection in general, and by injection I mean also cross-site scripting issues. So a common issue is the SQL injection, and the OWASP benchmark contains quite a lot of test cases on the on SQL injections issues. What is an SQL injection? It is a situation in which you have a user input that flows into an SQL query without being sanitized. The classical example is that you have a web page that takes as a parameter the user identifier, and then you take that parameter and you perform an SQL query in which you say, look, select from users where ID equals the parameter, the value that is given to you by the user. However, a hacker, a malicious user, might, instead of putting there just a numerical value, he might be putting there, I don't know, 1 or true. And in this way, we will gain access to the whole table of users, so maybe stealing data from your database. Or even worse, might just saying one semicolon and then drop table. And in this way, it will exploit the SQL injection vulnerability in order just to delete values, data from your database. So this is definitely a very scary, let's say, vulnerabilities. As you can understand, there are different ways to perform this type of checks. Let's go here to the OWASP benchmark. So here I extrapolated few test cases, and I ran on these test cases the injection checker. Okay, so for instance, let's start from the 204, sorry, the number 8, first of all. In this case here, we have a request, okay, and we take a parameter from the request, and we concatenate it to a string. So we just call something from the parameter. We are performing an SQL query through a call statement, and we get a warning from Julia just saying, look, here you might have an SQL injection. And effectively, we can see that through this quite easy to see flow, we get a user input flowing into the SQL query without being sanitizer. For instance, here I ran also the Spotbox analysis. Here, Spotbox was not able to catch this because what Spotbox does is just to check if you're calling an API. It doesn't have a complete view of how data flow inside and through the different paths of the programs. It just checks syntactically single, let's say, lines of code or the abstract syntax tree of a single method. So in this case, we have a true alarm. This is definitely a problem that might happen. On test case 105, instead, we get a case in which there is an SQL query, and we can see here we get a warning from Spotbox that says, look, you are passing a non-constant string to an SQL statement that is an SQL injection warning for Spotbox. As you can see here, it's not saying there might be an SQL injection. It's saying there might be a non-constant value. That is something that is still acceptable. It might not be constant, but it might not contain user input. What Julia does here is not to report a warning. And this is correct. So this is a false alarm by Spotbox, and there is no report by Julia on a test case that is safe. But why this is safe? We can see here that there is an SQL query that concatenates, so it's a non-constant SQL query, a bar statement, a bar variable, where bar is initialized with some complicated but constant numerical computation. It's concatenated a constant string. If this condition would be false, but this is never the case and Julia sees it, then it would concatenate the param local variable that, as you can see here from line 55, might contain a user input. However, Julia detects that this is always true, and therefore we have a constant string, so we don't have any false alarms here. However, there are cases in which Julia also performs some checks and produce, this is the case here, a false alarm. Why in this case? Because there are some very complicated cases that Julia abstracts. We have a semantic model, but we need to perform some abstraction. The semantic model cannot be totally complete. And we can see here that we have an SQL query, like before, that is concatenating a bar local variable. And this bar local variable is initialized here to some values from a list. So this list is created, then we add a constant value, a user input, and another constant value. Then we remove the first element, that is this one, and we get the second one, that is more safe. However, Julia does not precisely track values over the list because this would be definitely too expensive. So of course, when you're applying a static analyzer, you also need to do some manual inspection. However, these are corner cases. As we have shown the other time with the results of the OWASP benchmark, on average, the rate of false alarms on this benchmark is about 10%. And as you can see, this is really an ad hoc piece of code. In this case, both a syntactic analyzer like Spotbox and the semantic analyzer like Julia produce a false alarm. What is very important, as usual, is to carefully read the say documentation of the analysis. As the message of Spotbox said, what they are checking is just if you are passing a constant string to an SQL query or not. Of course, if you're doing anything interesting on the database, you are not passing an SQL as constant string. So you might end up with quite a lot of false alarm. Instead, what Julia does is to do an explicit flow of all the information inside the program, so a very semantic analysis, tracking in particular how user input flows inside this analysis. And using some rather complicated mathematical theories, check if this user input flows into the SQL query. Of course, this is a very wide word, so if you're interested to check more details about our checkers, there is a very deep technical section inside our website where you can see, first of all, the manuals of the different IDEs. So this might help you to go through all the things I was showing you during this demo, in particular at the beginning with the Eclipse plugin. There is a reference manual with all the information about the Julia analysis. But then we have also a complete list of all our checkers. From there, you can go into the details of the analysis we run, the different types of analysis, the different types of warnings. And here you can see there are all the checkers, and for each checkers you get quite a lot of information on the checks that are performed by the checker. And then there are also some brief tutorial about the analysis we run and how to set up your environment. And in any case, if you have any further question or anything else, you can drop us an email to pietro.ferrari@juliasoft.com or to sana.caglio@juliasoft.com. And of course, with our partner Nohau, they can drive you if you are willing to do a demo, an on-site demo, or you want to see more technical details. So this ends up from my side the webinar. I don't know if any of you has any question, but I think it was enough for today.
Yeah, if you have any question, you can send the chat. Sanna, do you have anything to add?
Well, I'd just like to add, thank you for everybody. And also, if you have questions, if you want to try our service on the web service, portal.juliasoft.com, just send us an email to our support or also to my personal address.
Yeah.
So I thank you, Nohau, and everybody who attended.
One question, Sanna.
Yeah.
Will there be support for Qt?
Sorry?
Will there be support for Qt or Qt, this graphical framework?
So we have support for different Java and C# frameworks. I'm not sure about Qt, but currently we have a way also to support new frameworks. So what we analyze is bytecode, Java and .NET bytecode. For frameworks, we have a support of different frameworks. I don't think we have anything embedded on Qt, but if there is interest on this, we can easily add the support also of this framework. Otherwise, one can anyway run the analysis. In some cases, there are frameworks that are rather complicated and might raise more false alarms than what you can see, for instance, in the benchmark or on standard, let's say, Java or .NET software. But the knowledge of Julia can be always augmented from a semantic point of view to support this type of frameworks.
Okay.
This is also because we have a research lab inside the company, so we do all the development ourselves. When there are customers who would need something support, for example, for a new framework, we simply do, of course, an evaluation of the effort and we insert it in the roadmap. So no problem usually to add features of this type.
Okay. Yes, thank you very much for this webinar, and yeah, please contact us at Nohau if you are interested. And I thank you, Pietro and Sanna.
Thank you.
Thanks, Joachim. Bye, everybody. Have a good weekend.
Bye.
Bye.